Hi, this video covers the basics of fractions. We're going to first talk about prime numbers and then about how to simplify fractions to lowest terms, switching between improper fractions and mixed numbers, and then also some operations with fractions in the next section. But section 1.3 is what we'll cover first, and we're going to start out with some definitions. The first definition is, what does it mean for a natural number to be factored? It says a natural number can be factored if it can be written as a blank of two or more numbers, and the fill-in that we're looking for there is product. So a number can be factored if it can be written as a product of two or more factors. For example, 12 can be factored because 12 can be rewritten as 3 times 4, or 2 times 6, or 1 times 12. One more definition. A natural number is said to be prime if it is greater than 1 and its only factors are the number 1 and itself. If a number is not prime, it is called composite. Okay, so let's go ahead and look at what the first 10 prime numbers are. We said a number is prime if it's greater than 1 and its only two factors are 1 and itself. So we have to start out with numbers bigger than 1. The next number after 1 is 2. 2 is a prime number because its only factors are 1 and itself 2. Same goes with 3. 4 is not a prime number because 4 can be, 4 is composite. It can be multiplied. You can multiply 2 times 2 to get 4. So there's other options besides 1 times 4. There's 2 times 2. 5 on the other hand is, because only 1 times 5 equals 5. 6 is not prime because 6 has factors of 2 times 3, which are other than 1 in itself. About 7. Is 7 prime? Yes, very good. 8 is not, 9 is not, 10 is not, 10 is 2 times 5, but 11 is. What about 12? What do you think about 12? Is 12 prime? Nope, you got different factors there of 12 other than 1 and 12. You have 2, you have 3, you have 4, you have 6. 13, however, is prime. 14 is not, 15 is not, 16 is not, but 17 is. 18 is not, but 19 is. 20 is, 21 is, 22 is not prime. So all those 20, 21, 22 are not prime. 23 is. How many do we have there so far? 1, 2, 3, 4, 5, 6, 7, 8, 9. We're looking for one more prime number. How about the number 29? The next odd one's 25 is not because 5 times 5 is 25. 27 is not because 3 times 9 is 27. But 29 is a prime number. And this list just goes on and on and on. In fact, there are competitions where people make lots of money nowadays to figure out what the next greatest prime number is. And really, you can only use computers to help you figure that out. Okay, so then we have this little note here. It says when a number is not prime, we can factor it into a product of all prime numbers. We call this its prime factorization. And the primary way that we see people write out a prime factorization is by using factoring trees, although there are other ways. So a factoring tree, hopefully you've seen this before, you just basically break a number down into its prime factors. So let's go ahead and do that. I don't know why that showed up there. So since 288 is an even number, we know it's divisible by 2. And 2 times 144 is 288. 144 is still prime, so 2 goes into that. 77 times. 77 is divisible by 7 and 11. And if you look up here, 7 and 11, those are both on our primes list. So the prime factorization of 288 is 2 times 2 times 7 times 11. For the prime factorization, you're just looking at these prime factors that are at the bottom of the tree. Of course, another way to write this would be, since there's two factors of 2, we could write this as 2 squared. We'll talk about exponents a little later. So either one of these are okay. This is probably the preferred answer. Okay. And then we can also talk about simplifying fractions. Fractions are numbers that have the form where there's a number on the top and the number on the bottom. Specifically, we call the top number the numerator, and the bottom number we call the denominator. A fraction is said to be in its lowest terms if the numerator and denominator do not have any common factors other than 1. So let's go ahead and simplify this fraction. We need to divide out any common factors other than 1 that go into both the top number, the numerator, and the bottom number, the denominator. So since both of these numbers, you'll notice, have 5 as their last digit, that means that they're both divisible by 5. So 5 goes into 165 33 times, and 5 goes into 385 77 times. So both of these are divisible by 5. That gives us a new fraction, and we need to again ask ourselves the question, is this fraction in its lowest terms? Are there any common factors? And the answer to that question would be no, because, well, 33 is divisible by 11, and 77 is divisible by 11. So if I divide 33 by 11, I get 3, and if I divide 77 by 11, I get 7. And so now, of course, these are both we recognize as prime numbers, so this is going to be as far as we can reduce. We get 3 over 7 is the fraction reduced to lowest terms. Now, a lot of times we see this written out in a different way. A lot of times people will, when they're simplifying fractions, they'll just go ahead and write it like this. This is divisible by 5, we get 33. This is divisible by 5, we get 77, and then 11 goes into 33 3 times, and 11 goes into 77 7 times, and so this is 3 over 7. One other way to do this is to do the prime factorization, so I can take 165 and factor that into 5 times 33. 33 breaks into 3 times 11. And then 385 breaks into 5 times 77, and 77 is 7 times 11. And so my fraction, my 165 over 385, could be rewritten where the top number is in its prime factorization. It's the numbers 3 times 5 times 11. And then we do the same thing for the bottom, which is 5 times 7 times 11. And then we just cancel out the common factors. We see that the top and bottom both have a 5, and the top and bottom both have an 11. So what's that leave us with? And simply see it leaves us with the 3 and the 7. Again, we get to the same answer. And I don't care which one of these methods you use, but you should be able to reduce fractions. the last thing we're going to do in this section, section 1.3, is talk about mixed numbers and improper fractions and how to convert back and forth between the two. If you want to convert an improper fraction, which is a improper fraction, you'll remember, is a number where the numerator, which in this case is 7, is bigger than the denominator, which is 3. And when that's the case, when the top is a bigger number, it's called an improper fraction. A mixed number, on the other hand, takes that and converts it to a number where it has a whole number and then a fractional part. So if we want to go ahead and convert an improper fraction to a mixed number, the first thing we do is we go ahead and divide the numerator by the denominator. And when you do that with long division, you take 7 and divide it by 3. Of course, 3 goes into 7 2 times. 2 times 3 is 6, with a remainder of 1. So it gets rewritten as the whole number part, goes in front, and then it has a remainder of 1 out of 3. So we could go ahead and do that with the example here. We want to go ahead and take 57 and divide it by 5. Well, 5 goes into 57 11 times. Actually, let's just go to the first number. I'm sorry. 5 goes into 5 once. 1 times 5 is 5. If I go ahead and subtract that, I get 0, but then I go ahead and bring down the 7. 5 goes into 7 one time. 1 times 5 is 5, with a remainder of 2. So we take our whole number part, which is up here on top, that's the 11, and the remainder is 2 out of 5. So 57 over 5 is the same as 11 2/5. Okay, we're also going to talk about how to convert the opposite way. How do we convert that mixed number back to an improper fraction? And it's a 3-step process. Most of you have probably done this many times before. You multiply the denominator by the whole number to get 8, and then you take that 2 times 4 and you add the numerator to it, which in this case is 1. So 2 times 4 is 8, plus 1 is 9, and then you write that over the denominator of 2. So this would be 2 times 4 plus 1 is 9, and then you leave 2 as the denominator. And you see it written out right here. So another example of that, if I want to convert 9 3/4 to an improper fraction, I take 9 times 4. 9 times 4 is 36, and I add 3 to that. So 9 times 4 plus 3, which is 36 plus 3. This is going to be 39 over 4. That's how we convert 9 3/4 to an improper fraction. So section 1.4, we deal with operations of fractions. We're talking adding, subtracting, multiplying, dividing. These are, again, hopefully things you've done before, but we're going to go ahead and review it. A couple notes to remember about multiplying fractions is that when you multiply fractions, you multiply the numerators together and the denominators together. And then a lot of times it's easier to simplify first, if possible. We can't always, but when you can, you should try to simplify first. It will make your life a whole lot easier. So I'm going to go ahead and jump right into an example. You notice this is a case where we want to simplify first. 15 doesn't necessarily go into 16, but if I look over here between the 15 and the 25, well, those are both divisible by 5. So 5 goes into 15 3 times, and then 5 goes into 25 5 times. And if I look the other way, well, 14 and 16, both of those are divisible by 2. So 2 goes into 14 7 times, and 2 goes into 16 8 times. Now I've simplified. Now let's go ahead and multiply across. Let's multiply the numerators times the numerators and the denominators times the denominators. And I'm not going to multiply 15 by 14 because I've already reduced those. I've reduced them to 3 and 7. And 3 times 7 is 21. Same thing on the bottom. We're not multiplying 16 times 25. We're multiplying 8 times 5, which is 40. And 21, of course, is divisible by 3 and 7, but 3 and 7 do not go into 40. So we are done simplifying that first one. We can take a look at another one, example B. Well, this is not a fraction times a fraction, it's a whole number times a fraction, but you can always turn a whole number into a fraction by what? Hopefully you're thinking, put it over 1. So now I have 8 over 1 times 1 over 5, and if we again multiply the numerators together and the denominators together, 8 times 1 is 8, and then 1 times 5 is 5. Okay. Moving on to example C. Well, here we have a fraction times a mixed number. What might be a good thing to do first here? Hopefully you're thinking, well, let's change that mixed number to an improper fraction. That's what I would do. So I'm going to rewrite this as negative 2/3 times, well, we just did this. 2 times 8 is 16, and 16 plus 5 is 21, and we keep our denominator of 8. And then again, just like in example A, we want to ask ourselves, can we do any simplifying? And the answer is yes, because 2 goes into 2 once, 2 goes into 8 4 times, and then over here 3 goes into 3 once, 3 goes into 21 7 times. And then we go ahead and multiply. Remember our rules for multiplying signed numbers. We have a negative number here times a positive number, and a negative times a positive is a negative. We multiply the numerators. 1 times 7 is 7, and then the denominator, 1 times 4 is 4. So the answer here is negative 7 over 4. Again, we can move down to the bottom here. First ask if we can do any simplifying. Hopefully you see that, yeah, 3 goes into 9 3 times. This is a 1, and then 4 goes into 4 once. So this simplifies greatly. And then we can also notice that both of these numbers are negative, and remember that a negative times a negative will make a positive. So this is a positive 1 times 4. A positive 1 times 4, which is 4, and then on the bottom we have 3. So this simplifies to 4/3. And these are just some examples of how we go ahead and multiply fractions. Now dividing fractions is very similar to multiplying. In fact, multiplication and division are related. So a couple of notes here. When we flip a fraction upside down, the resulting fraction is called the reciprocal of the original fraction. For example, 6 over 7 and 7 over 6, notice they're flipped or inverted. Those are called reciprocal fractions. And so we then have what's called the reciprocal property, which says that if we multiply two reciprocals, a over b times b over a, we should notice that we're going to get the b's cancel and the a's cancel. What's left? Everything cancels. We're just left with 1. And so the way we're going to divide is we're going to use this property of inverting, or the reciprocal, because dividing is the same as multiplying by the reciprocal. Again, this is probably something you've done before. Example A, what we can do is we can say, okay, 9 over 28 is this divided by negative 21 over 20 is the same as taking 9 over 28 and multiplying. So I'm changing this division sign to a multiply sign, and then I'm going to multiply by the reciprocal of this fraction. So it's still going to be negative, but instead of 21 over 20, it's going to be 20 over 21. Again, we want to ask if we can simplify. So 9 and 21, those are both divisible by 3. 3 goes into 9 3 times. It goes into 21 7 times. And we also have 20 and 28, which are both divisible by 4. 4 goes into 25 times. 4 goes into 28 7 times. This is a positive fraction times a negative fraction, so my final answer should be negative. On the top we have 3 times 5, which is 15. And on the bottom we have 7 times 7, which is 49. Again, we have another one here, but notice our second number is a mixed number. So what do we want to do with that? Just like we did before, we want to go ahead and turn this into a improper fraction. So we take 2 times 3 is 6. We add 2 to 6, we get 8 over 3. So this problem can be rewritten as 20 over 21 divided by 8 over 3. But we don't want to do division, we want to invert and multiply. So we're going to take 20 over 21. We're going to take this divide and turn it into a multiply, and then take the reciprocal of 8 over 3, which is 3 over 8. Moving on and simplifying, 3 goes into 21 7 times. Both 4 goes into both 8 and 20, so 4 goes into 8 twice, and 4 goes into 20 5 times, leaving an answer of 5 over 14. So we've now talked about multiplying and dividing fractions. Let's go ahead and move on to adding and subtracting. And one important thing to remember when we have to add or subtract fractions is that it's necessary to have a common what? A common denominator. This is again something you've hopefully done before, but we're going to review it. You do not need to have a common denominator when we are multiplying or dividing like the previous examples, but whenever we're adding or subtracting, we do need a common denominator. So you'll notice here, if I want to subtract 7 over 16 minus 1 over 16, those are common denominators. These are common denominators. So we can just go ahead and subtract. And the way we subtract is we subtract the top numbers. 7 minus 1 is 6, and the denominator stays the same. So we take 7/16 and we subtract away 1/16. We're left with 6/16. We again need to ask if we can reduce, and we can. Top number is divisible and the bottom number are both divisible by 2, so this reduces to 3 over 8. So that answer is 3 over 8. And the same thing holds with mixed numbers. If I go ahead and add and subtract them, I need the fraction part to be a common denominator, which you'll notice again here that these are the same. So when you add or subtract mixed numbers, you add or subtract the whole number part. 5 plus 6 is 11. And then here, instead of subtracting, we're adding. So we're going to take 1/8 plus 5/8 is 6/8, which of course reduces. Those are both divisible by 2, so this reduces to 3 and 4. So I get a final answer here of 11 and 3/4. Okay, so both of those examples had common denominators, but sometimes we don't have a common denominator, and so we need to find what's called the least common denominator. And this is sometimes hard for students to do. We're going to look at kind of a structured process of how to find a least common denominator or a least common multiple, but sometimes it's easier once you get the hang of it just to kind of see it in your head, because what you're really looking for is the smallest number that both 12 and 20 go into. When you're trying to find the least common denominator, you're looking for the smallest number that they both divide into, which may or may not be hard if you're talking about numbers like 12 and 20. What are two numbers that, or what's a number that both 12 and 20 go into? If that's not obvious, then you may want to follow the approach here, these 3 steps. So notice it says in step 1, find the prime factorization of each denominator or each number. So in this case 12 and 20, we need to find the prime factorization of both of those. So if I do that, 12 is 3 times 4 and 4 is 2 times 2. So that prime factorization is 2 times 2 times 3. I'm going to do the same thing with the other number, 20. 20 is 5 times 4. 4 is 2 times 2. So this is 2 times 2 times 5. And so the least common multiple, if we move on to step 2 here, is to find the common factors of the denominators. Common factors are the ones that they have that are the same. I'm going to go ahead and highlight that in green. So notice that both of these prime factorizations have 2 2's. So if I list that here, I have 2 times 2. And then in step 3 it says multiply the common factors, those are the 2 times 2, by the remaining factors in the denominator, which the remaining factors are the ones that are not the same. I'm going to go ahead and highlight those in blue. That's the 3 and the 5. Those are the different ones. And so I'm going to multiply the common ones with the 2 extras, the 3 and the 5. And that's how I'm going to find my least common multiple. So if we multiply that out, 2 times 2 is 4, 4 times 3 is 12, and 5 times 12 is 60. So my least common multiple is 60. The other way to do this is to just start writing multiples, and a lot of times this is what people will do in their head. However, with bigger numbers this gets a little bit more tricky. So if you start writing multiples of the two numbers, for example, multiples of 12 are 12, 24, 36, and so on. Multiples of 20 are 20, 40. None of these are the same yet. 60, maybe do some more here. 48, 4 times 12 is 48, 3 times 12 is 36. The next one would be 5 times 12, which is 60, and then lo and behold, look what we have here. We have that 60 is the least common multiple. It's the smallest number that both 12 and 20 will divide into. So if you can do this sort of thing in your head or even list that on paper, feel free to, but there's also this more structured approach for those of you that don't like that method. So when I want to find the least common denominator of something, I'm really just going to take the two bottom numbers. I'm going to take 18 and 14, and I'm going to do the same approach that we did in the previous example. So 18 is 2 times 9, 9 factors into 3 times 3. So this is 2 times 3 times 3. And then 14 is 2 times 7. So this is 2 times 7. So my least common denominator, we take the factors that are the same. I take the factors that are the same, which is they both have 1, 2, and then I multiply them by the factors that are different, which is 2 3's and a 7. So my answer is I'm going to take the factors that's the same, there's 1, 2, and multiply it by what's left in blue, 3, 3, and 7. This is a bit of a bigger number. I'm going to go ahead and multiply 3 times 3 first, which is 9. 9 times 7 is 63, and 63 times 2, this is 126, is the least common denominator. That's the smallest number that 18 and the 14 both divide into. So let's go ahead and use this knowledge to add and subtract in these two examples. Notice that here 2/9 plus 4/15, 9 and 15 are not common denominators. So what I need to do is find a common denominator, find a number that 9 and 15 both go into. And we could use the same approach we did before. Take our 9, which is 3 times 3. Take our 15, which is 3 times 5. So our least common denominator has got to be, well, it's what they have in common. They both have 1, 3 in common, times what's different? Another 3 and another 5. 3 times 3 is 9, 9 times 5 is 45. So if I look at 2/9 plus 4/15, those denominators both need to be 45. So we're going to ask ourselves, what do I need to multiply the 9 by, and what do I need to multiply the 15 by to get 45? And so what I'm going to do here is I'm going to take my 2/9, and notice that to get 45 I need to multiply this by 5, which means I also need to multiply the top by 5. 2 times 5 is 10, 9 times 5 is 45. Same thing with the other answer. I'm going to take my 4/15. What do I need to multiply the top and bottom by to get 45 for the bottom? Well, I need to multiply 45 by, or 15 by 3 to get 45. But if I multiply the bottom by 3, I need to multiply the top by 3. So this one becomes 12 over 45. So what I'm really adding up here is I'm adding 10 over 45 plus 12 over 45. 10 plus 12 is 22 out of 45. Okay, last example. Remember, I need this to be a fraction, so I'm going to write it over 1. This is a case where it's a little easier to see what the common denominator is, because both of these denominators, 1 and 4, can become 4. I have 2 over 1, which I can turn into 4 by multiplying the top and bottom by 4. So that's going to be 8 over 4 minus 3 over 4. So now I'm going to subtract. 8 minus 3 is 5 over 4. Okay? I know fractions are not everybody's favorite thing to work on, but this is something we need to review. So go ahead and try the homework on these, and we will talk about these more in class. Thank you.